The second day for chapter 11 is what we're starting today. If you're following along in your textbook, which I'm pretty sure nobody is, but if you are, this is 11.4. This is about irrational square roots. So basically square roots when they're not perfect squares. So yesterday it just worked out each time. You know, we had this every number inside the radical was a repeater and the radical went away. Did you guys notice that everything worked out really nicely yesterday? Today we're looking at ones where they don't work out so nicely. All right. So here is a review. Okay, so square root 50 is not a perfect square, right? There's no number times itself that would give us a 50. So you try to think of, well, what are the perfect squares that are close to 50?
49.
So 49 is a perfect square. So I'm going to think of the square root of 49. So the square root of 49 is 7, right? And 50 is a little bit bigger than that. So go up to 8. What is 8 squared? 64. So do you agree that the square root of 50 has to be somewhere between the square root of 49 and the square root of 64?
Yes.
Okay, so the square root of 50 has to be between the numbers 7 and 8 when you simplify it. Which one is it going to be closer to?
7.
The 7, because it's closer to 49 than it is to 64. And these you can actually double check because you can type it into the calculator. And yeah, what did it say 7.2?
I just guessed.
Oh, I was going to say, I'm sure it's real close to 7.1.
So
Okay, so your answer is just that it would be in between 7 and 8.
Oh.
This is a perfect square. What is the square root of 196?
14.
It is 14. Good. Now, technically up here it asks what it's closer to, so you'd say closer to 7. We kind of talked about it. We didn't write it down. If you want to add that, or just put an arrow to 7, closer to the 7. It just said, there was part of the question that we didn't answer. See how it says, which one is it closer to? We talked about it, but I didn't write it down. So if you want to, just put like closer to the 7.
Do we have to do that?
If it asks which one it's closer to, tell me which one it's closer to. But these are just notes, so it's not a huge deal if you don't add it. All right, any questions? Okay, so when they ask which one is it closer to and it's not a perfect square, just think of what are the perfect squares right around that number, which ones does it fall in between, so which numbers would that put your actual answer in between. Now, here I don't want an approximation, I don't want a rounded answer, I want to simplify the radical. So we're going to do that by making a tree. Just like the tree we did yesterday, you could do 5 and 10 if you want. I did 2 and 25. I'm going to circle the 2 because it's prime. 25 is what? 5 and 5. Good. Those are both prime. Now, I said it a few times yesterday, but it probably didn't mean much at the time because everything had a partner. But I kept saying you need a friend to go play outside. Okay? Who has a friend here?
5.
The 5s. The 5s are going to go outside. Who doesn't have a friend?
2.
The 2. The 2 stuck inside. So the 2 stays inside the radical. It doesn't have a friend to play outside with. The 5s come together. They're hand in hand. You put 1 5 outside the radical. Yes?
So does that mean 5 times the square root of 2?
Yes. So the answer is 5 times the square root of 2. And I like to double check these. So if it's inside the radical, there would be 2 of them. When it's outside the radical, there's only 1. So if you put this back inside the radical and have 2 5s, does 2 times 5 give you what you started with? And it does. So that's kind of how you can check this. Each number out here, you'd square it each number in here, you'd have it once, and you should end up right back here. All right, here's another one, square root 63. So we're going to do the same approach. We're going to do a tree. We're going to see who has a buddy and go play outside, who's stuck in the inside. Yes?
3 and 21.
I'm just going to do 7 and 9. 3 and 21 actually works too. 7 is prime, and then 9 is 3 and 3. So who has a friend?
3.
The 3s. So I'll have a 3 outside the radical, and then what's on the inside of the radical? 7.
I have a question.
Yes.
How do you solve this? 3, 7.
You would say 3 square root 7.
And that's the answer.
That's how you'd say it out
I
loud.
want to solve it.
If you want a decimal,
Yeah.
you can just type it in the calculator.
Oh.
You could type in either one. Square root's 63 or 3 times square root 7. If I ask you to simplify this on a test, if you give me the decimal, it will be completely wrong. Okay, simplify means make the factor tree. If I want you to type it in the calculator, it'll say type in the calculator and round to the nearest whatever. All right, here's the next one. Notice there's an 8 out front, which means anything that you pull out to the front, you'd have to also multiply by the 8. All right, so let's start a tree for 75. I'm doing 3 and 25. 3 is prime. 25 is 5 and 5. Now those are prime. So who can go outside? The 5. So there's already a 5. There's already an 8 out there. You're bringing a 5 out there. What's 8 times 5? 40. And then the 3 still doesn't have a partner. Now, if you have more than one thing left in the square root, those numbers get multiplied back out. Anything outside gets multiplied by what's outside. Okay? What are your questions? All right, here's the next one. 2 times square root 90.
30.
Lots of options. 9 and 10 works. 30 and 3 would work as well. I heard someone say that. However you want to do it, go for it. 9 is 3 times 3. 10 is 2 times 5. Who's got a friend?
2.
The 3, and then there's already a 2 out there.
Oh, so you don't put the 2's together?
No, that's a good question. This 2 is this 2 is already outside. Okay, it can't bring this 2 with it. Okay, he's already out front. He's coming out front. These 2 are stuck inside together. They don't match. They're not repeaters. So I have a 2 and a 3 out front. I have a 2 and a 5 in the inside. So what do I have in the front? 6. Square root 10. All right. Yes.
That one, could you divide by 2 on the inside is outside?
Nope, you don't reduce these. If it's a fraction inside the square root, you could reduce. Or if there's a fraction on the outside, but no, this isn't anything that you would reduce, no. All right. Square root 96. So we need to do a factor tree.
2 and 48.
All right, so I did 2 and 48. 48 is 2 and 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3.
So we would have 2 2s.
Yes, 2 pairs of 2s. So a 2 comes out, a 2 comes out. And then on the inside, you have a 2 and a 3. Neither one of them have a partner, so they're stuck on the inside. So 2 times 2 is 4 on the outside. 2 times 3 is 6 on the inside.
Yeah.
All right, here's the next one. All right, so do a factor tree for 80. Sometimes I see students wanting to do a factor tree for the number on the outside. We don't care what the 2 is made of. We don't care if there's any repeaters. It's already on the outside. Everybody's outside playing. Don't worry about it. The one you need the tree for is the one in the square root.
So don't care about these.
We don't care about the 2. We don't need a tree for the 2. Just anything that you pull out of the square root has to multiply by the 2. That's the only way the 2 affects anything. It can't partner with the inside. It can't do anything with the inside. All right, so 80 is 2 and 40. 2 is prime. 40 is 2 and 20. 2 is prime. 20 is 2 and 10. 2 is prime. 10 is 2 and 5. 2 is prime. I've got 2 pairs of 2s. So 2 comes out. 2 comes out. So how many 2s do I have outside of my radical? 3 of them. The one that was already out there, and then 2 from the 2 pairs of 2s. And then the lonely old 5. What is 2 times 2 times 2? 8. All right. I want you guys to try this one. So let's talk in like a minute. See how you do. All right, so the way I did it, and again, your tree can look differently as long as you have the same prime number. So you should have a 3. Hold on. This is not how I would have done this. Let me take over. We're going off the map. Let me back up.
He's going off the rails.
I'm going
crazy.
I'm going rogue. Hold on. Okay, so if I would have done this, yeah, so you do 2 and 5. 2 and 5. Those are prime. Okay, so who's coming out to play?
The 5s.
The 5s and the 2s. What is 5 times 2? 10. So when this presentation was made, they said, well, hey, 10's a repeater, and they stopped there. I always go till it's all the way prime, which I'm hoping you did as well, and then you just figure it out from there. So I started with a 5 out front, then another 2, then another 5, and then who's left on the inside? The 3. Okay, so what is 5 times 2 times 5? 50. So did you end up with 50 square root 3?
Yes.
Okay. Wonderful. Any questions? Yes.
What if you did it 2 and 150?
2 and 150?
You get the same thing. You'll get the same.
Then did you do 15 and 10?
No, I did 75 and 2.
Hold on. What?
I did 5 and 30.
Okay. Then what?
Got 5 and 6.
Okay.
Hold on, wait, I see where I messed up.
Okay, yeah, you should end up with the same prime numbers, so you should have the same repeaters.
There's lots of words.
Yeah.
I put a 7 instead of a 6.
Oh, yeah, that'll mess you up. All right, other questions? Anyone else want me to check their tree, see what they did?
Tomorrow's Friday.
Wait, tomorrow's Friday? No.
Yes, dude.
Bless. Dude, my ears hurt.
That is some crazy sneezing. Okay, back to this. So 5 and 27. 5 is prime. What about 27? 9 and 3. 3 is prime. 3 and 3 again. Now, there are 3 3s. Do you think they all get to come out? No, only pairs. So a pair of 3s. So yes, out front we have a 3 and a 4. On the inside we have the poor 3 that just feeling left out, and the 5. So what's my final answer?
36 and 15.
36.
What? No.
4 times
12.
12, yeah.
I'm sorry.
All right, now hold on. What?
I'll multiply by 9.
Oh, okay. Yeah, so that's a common mistake too, is some people, they go like up into the tree. You're only looking at the bottom branches, the prime numbers, okay? So 9 would not be one of the numbers inside or outside because we broke it down further. Any other questions? All right, what do we learn about today?
A rational square root.
Yeah, so you can just put square roots.
I mean, ISR.
Sounds good. All right, so here's what the rest of the class is going to look like. I am going to give you your homework. You're going to have about 10 minutes to work on it. After 10 minutes, I'm going to pass out those quizzes from chapter 6.5, and then we'll spend some time going over those as well. Okay?